Pakistan is eager for progress. While others still use traditional sand casting methods, this roller workshop has already adopted centrifugal casting. It has advanced equipment, and its annual revenue reaches several million. They recycle large scrap iron as raw materials to maximize the workshop's profits. Although a pile of random scrap iron may seem worthless, the hardworking people of Pakistan truly turn waste into treasure. This peculiar cylindrical melting furnace is the primary tool for smelting scrap iron into molten metal. Unlike traditional cupolas, it requires a continuous supply of heavy brown oil, ignited and transformed into the high-temperature heat necessary for the furnace via a large blower, enabling the heavy crude to burn intensely. Of course, centrifugal casting also requires molds. Before use, they are wiped clean to prevent impurities from entering the formed roller. Casting platforms are set up on both sides to increase the efficiency of the process by quickly filling the mold with molten iron. Next, the single-cylinder diesel engine is started, and through a belt connection, the rotating shaft drives the centrifugal drum, preventing air pockets in the formed roller. The scrap iron is now heated and melted by the burning heavy oil, and it can be poured into smaller containers. However, large rollers require a lot of molten iron, and one container is insufficient. So, casting is done simultaneously on both sides, with the rotating shaft at the base driving the centrifugal drum to ensure the molten iron adheres to the inner wall. Even for hollow castings, no core is needed for shaping. This hollow circular casting forms the roller's drum, but the craftsman begins precision machining since it's still rough. While centrifugal casting eliminates air pockets and slags to ensure flat end surfaces, a lathe and hammer remove excess material that exceeds the standard length. The roller is then moved to lathe number 2. As the shaft head needs to be embedded, a sizable boring bar is fixed to smooth the rough, good inner wall. The chuck then drives the bar for cutting. Cast rollers can't be formed in one piece centrifugally, so hollow ends need shaft heads installed to drive the roller. Although they use a segmented production process, the craftsman's meticulous use of an outside micrometer shows their precision. The shaft heads are forged, which significantly increases the cutting difficulty. After repeated micrometer measurements, the shaft heads are ready to be assembled with the roller. Given the large contact surface of the shaft heads, it isn't easy to hammer them into the roller, so the craftsman heats both ends with liquefied gas. Using the principle of thermal expansion and contraction, the shaft heads are easily fitted. True to the saying, big factories freeze, small factories hammer, Pakistanis use fire. But assembly alone isn't enough. To meet factory standards, the roller requires further finishing, secured tightly by a lathe chuck and tailstock. Even though the roller is over a meter long, the lathe easily handles it. The surface still needs grooving, so the craftsman carefully controls the depth of each cut, shaving several millimeters off the surface. This corrects misalignment and enhances the overall finish. With precise polishing, the shaft heads pass micrometer inspection. Since the shaft heads need to fit bearings and be tightly secured, milling a keyway with a motorized cutter is essential to prevent slipping. Although they don't have high-end imported milling machines, Pakistani machinists never complain about their equipment. They maximize their tools' utility, reflecting their deep sense of achievement. Once the finely machined roller is secured on the planing machine for gap adjustment, the groove surface becomes a crucial feature for the rolling mill's rollers. Despite the planing machine's slower operation, its precision remains flawless. After 2 hours of machining, the large roller, made from scrap iron, is ready for shipment. What do you think of this manufacturing process?